So we've seen that by using either particles or volumes, we can maybe capture the dynamic movement of a liquid. And in both cases, we can get to the final result of a polygon mesh. But which to use? Particles or volumes? Here's just a, basic particle approach. If we were literally to just have a source of particles that fall from gravity into a container, which we can't see, and what happens? Well, just particles on its own, it just positions velocities and then collide. So nothing really is happening here that looks like a liquid. It falls, it collides, which I guess is something, but there's no sense of volume to it. There's no mass, there's no tank of water. So we can't just do particles on its own, which of course not, or else we wouldn't be talking about flow. Now, there is another form of a particle fluid sim called SPH, which means smooth particle hydrodynamics. This was created to study gases in stars and other interstellar things. It's been around for a very long time. It was adapted by earlier things like RealFlow to be the standard liquid simulation of choice for a long time, but it has always suffered from some pretty severe drawbacks. The drawbacks really are that it takes a very long time to simulate a high quality simulation. Here we can see a low quality simulation where all the particles are very busy, they're jumping around, and yes, we do get more of a sense of volume, way better than the previous thing we just saw. It fills up the tank, and the tank is filling up vertically as well, but it's very, very busy. Now, SPH doesn't have to look like this, but you need to give it lots of sub-steps. You need to give the simulation many additional chances, more time, basically, to come up with a good solution. This is a very bad solution. This is me not giving it nearly enough time to come up with a good solution, but I just wanted to demonstrate this is what you might get with very low substeps, but it also is indicative of the kind of issue you run into. With SPH, all of the particles are pushing every other particle away. So you end up with this very noisy kind of look. Until, again, you give it a lot more frames to solve with. But it just ends up taking too long. It doesn't scale very well. If you needed to do like a raging river or something, you're just completely out of luck. So even these days, SPH can be good for a smaller scale simulation, but it's very bad for large scale simulations. So it looks like particles are not going to cut it. Why does that not surprise me? So let's talk about volumes. So here's a volume-based approach where the volume you see is what we call a level set or surface. I'll call it a surface volume from now on. So not a volume like the cloudy one that we saw in the previous chapter, not a fog density volume, but rather a surface volume, where the volume voxels are storing how far away you are from the closest surface. So in an area out here, it might say, oh, I'm 1 unit away. And then an area here might say, oh, I'm 0.25 units away. And then voxels on the inside of this might say, oh, I'm negative 0.25 away from the surface. I'm inside. So when we visualize a volume like that, we basically just draw kind of a surface where we switch over from being a positive distance away from the surface on the outside to being a negative distance away on the inside. Right here, we're 0 distance away from the surface, so we draw a temporary surface there. This is not polygons. This is still just showing a surface volume. So this is unlike SPH, which doesn't really have a presence in Houdini anymore, Houdini actually does, as of Houdini 17.5, still have a volume simulator in it. I'm not sure why, but I'm sure you could find a use for it. In any case, this is what it looks like. So this is already pretty cool. We get an initial splash, whee, like that. There's a few pretty big problems that these volumes liquid sims have always had, and this is the kind that Maya had for a long time. For one, it's already acting crazy. I barely set up anything about this sim, and you can see it fills up way too fast. Stuff like that has always kind of been the bane of volume sims. It just doesn't track how much volume is in it very well. So it's adding too much, and then ironically, on the other side, another common feature, or detriment I should say, to volume sims are objects, these chunks that are represented by little bits of volume, as they move through space, and this is true in volume sims in general, they tend to lose mass. They tend to lose volume. So if you track one of these things, you can see it got a little bit smaller, 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 and now it's gone. Anything that is small, like over here, they tend to just disappear. You can see it happening all over the place. So even if we were ever to get this crazy filling up under control, which admittedly we could do by just, hacking it and changing some stuff around, that kind of stuff is very hard to eliminate in volume simulations. If only we had some kind of particles that could not be lost. If only we had some kind of way to combine these two things. Oh, well, I guess we can't. So here's another one. I just had it fill up from nothing instead. Again, still fills up way too fast. Again, we can still see stuff disappearing before it should go. All right, so those are our best attempts with just particles or just volumes. So now in the next chapter, we're going to talk about the hybrid solution, which is, of course, flip.